So these are my transport layer content. We all know the transport layer, the two main protocols. Already we are discussing in the TCP/IP model itself. We have seen about the TCP and UDP. Okay, transmission control protocol and user datagram protocol. So the connection management, flow control, retransmission, congestion control. When you see with the data link layer, the transport layer also take all this responsibility like connection, end-to-end connection, and how my data is flowing. If there is no acknowledgement, I have to retransmit. If sometimes the congestion happens, how it will be recovered the data, okay, how it is resending and how it is putting in a sequence number. All this will be in the congestion diagram. And one more leaky bucket algorithm is there, and then detection and avoidance. So this is you are going to see. And today we try to see what is the basic principles of TCP and UDP. And in the other successive classes, we may see the other topics. Okay. So I think before entering into the fourth unit, our course outcome 4, every time we were seeing that we were satisfying the CO4. So you just see mainly when you go with our CO3, designing a routing protocol in a network and demonstrate how data packet will reach to the intended destination. So while we are seeing about this routing algorithm, we have seen the distance vector algorithm, link state algorithm, and how the data packet is delivering you with the help of internet protocols. Okay, DHCP we have seen, ARP we have seen, DGMP we have seen. So dynamic host control protocol, dynamic control message protocol and all. So all this we have covered in the CO3. In the CO4, we are supposed to know the flow control mechanism and how to regulate in the traffic in a network. So the entirely, we are going to learn about the transport layer. Okay, I told you each and every unit. CO1 covers unit 1, CO2 unit 3, 2, CO3 unit 3, and similarly CO4 unit 4. Okay, now I will go in directly into the transport layer. You just see, we all know that the upper and this is explained with the help of OSI model only. Okay, so my upper layer is session layer and my lower layer is network layer. So the transport layer is an intermediate layer. So how my packet will be received from the session layer and how it is transported to the network layer in my source side. In the destination side, obviously it is received. My data will be sent from the network layer and again it is transported to the session layer. And you all know to that the transport layer, always what it will do now, accept the data, split the data into small packets that we used to say. It will always accept and it will split into small packets and then it will send in the order. That's why we were telling one technical term in the transport layer is sequencing. Sequencing and segmentation both will be done in the transport layer. So the transport layer is responsible for splitting as well as rearranging in order, as well as it will send to the layer correspondingly. Okay. Okay, now I told you this is one of the key points. It is responsible for end-to-end transportation of data between the applications. And these are the major functions of the transport layer. Okay, I think I will explain you not in much detail because this entire unit is about these points only. I will tell you the introduction, what is the service and what is multiplexing and demultiplexing, segmentation, I told you, sequencing, reassembling, error correction, and flow control. These are the major functions of the transport layer. I think when you see with our data link layer, the same concept will come. But according to the segmentation, definitely you have a flow control will be there, error control will be there, all reassembling will be there. So this, apart from that, this all doing this, what the transport layer is doing, majorly doing, these are the major functions. So now we will see one by one. Ma'am, switch or hub need MAC address, router needs IP address. So both change in the previous case, ma'am. See, you all understand. I told you that particular example for wireless LAN. Okay, so switch or hub need MAC address. Yeah, definitely switch or hub. We all discussing about the network devices. We have seen that. I told you. Okay, for example, only I told router needs IP address. While I am sending that IP address, it always look up the MAC address also there. Okay, so I'm sending from my source to destination. Even the router is there. There will be a corresponding MAC address also will be there. So then only my packet, how it is taking the IP address. That's why I told you IP address is a fixed that cannot be changed. But the MAC address will be changed accordingly how my protocol is, how my data is delivered from one to another. You all know we were talking IP address in uh, network layer and a MAC address in data link layer, port address in transport layer. Okay, but you all know combined together while only this layer will take up this now. While we are seeing to that in header, when you see to that, I think one slide I will tell you. You all understand this. This will be happen. Okay, when you see to that, all my header will be keep on adding only. Finally, I will reach the data. So think that the hub only take the responsibility of that. Every time the header will be added. So when I'm taking my application layer, my data is there now. Automatically, the TCP header will comes into the picture where it will take the responsibility of port number, sequence number, and all. While come to the IP header, it will take the responsibility of IP addressing and all. While it comes to the frame header, automatically it will take the responsibility of adding MAC address. So while I'm correlating that, I told you that address resolution protocol will map the logical address with the MAC address. I told you. Yes, Nitesh, you are clear on this point? Okay. Now, these are the works I told you. You may note down after. We will see one by one. Okay, and I'm saying process to process delivery, end-to-end delivery, multiplexing and demultiplexing, conjunction control, data integrity and error correction, and flow control. So all the transport layer, I think the word multiplexing and demultiplexing, we have studied only in the circuit switching networks and all, but the transport layer, it is also one of the primary role on that. So while doing multiplexing and demultiplexing, definitely the time division multiplexing, frequency division multiplexing, the reliable data transfer, all it will be responsible. And you all know that this transport control protocol will be mainly with TCP and UDP. I think you may see to this, these are all TCP/IP protocol. So here we are mainly cover TCP and UDP. Okay, this is streamed control transmit protocol, but we will see according to our syllabus UDP and TCP now. Okay, I think this network layer protocol we have covered IP, ARP, okay, Internet Group Management Protocol, Internet Control Message Protocol, this and all we covered in the third unit. So this is our fourth unit, and you all know this is our fifth unit, and this is our third unit, and this is our second unit, and the entire model. Okay, actually this is TCP/IP model only we have given. So that's why session layer, application layer, presentation layer, everything is put it in a single one. Okay. So now we told you it is having a responsibility. We will see the responsibility one by one. Okay. Identifying a service, that is one of the major work of transport layer protocol. What is identifying a service? So I told you in the data transportation, mainly the two protocols are very, very important purpose. One is transmission control protocol and another one is user datagram protocol. Okay. What is TCP and what is UDP? While we are seeing that, it is connection oriented, it is connectionless. What is the meaning of that now? In TCP, I'm taking that, okay, I'm connecting via phone. I'm calling my friend and all. Definitely, my friend will pick up the phone and acknowledge me. That is connection oriented. Just means we are dialing and it is reached that, and they are sending some through voice call there. So that is connection. We are establishing a connection. But when you see UDP, it is connectionless. Very simple. I'm sending some messages, mail, all will be connectionless. We didn't wait for the acknowledgement at all. So it is a connectionless, and this is TCP is a connection oriented protocol. That is the one of the major difference between the TCP and UDP. TCP always expect for the acknowledgement, but when you go with UDP, there is no acknowledgement. That's why we are saying it's a connectionless protocol. Okay, and here you see it's a reliable communication with acknowledgement only we will send. Here it is an unreliable communication, no acknowledgements are there. Okay, and then when I'm saying this, every time I'm sending hello, how are you, then it is I am fine. Every time I'm getting acknowledgement only, I can understand I have sent one message that have been sent to that, I'm getting my acknowledgement. So it is a slow data transportation. Okay, it's a slow data transportation. And when I go with UDP, it is always a faster data transportation. Okay, and this is protocol number 6. Actually, accordingly, the protocol developed, they say protocol number 17. That's not a major one. And you all know what are the other protocols seems to be work like a TCP and all. HTTP, FTP, SMTP, hypertext transfer protocol, file transfer protocol, simple mail transfer protocol and all we are saying. And these are the examples of this. Similar to that of UDP, domain name service, okay, dynamic host control protocol, all this will be in the UDPs. But you understand this is the two major point. It is a connection oriented and it is a connectionless and unreliable communication without any acknowledgement. Okay, this is my first job of my transport layer, that is identifying a service, whether it is a TCP or UDP, because you all know service are identified with the help of port number. For each port number, we can say to that this will supported by the TCP and this will supported by the UDP. I think I will show you. You are seeing that these are the port which is supported by TCP. Okay, port 7. Port 9, port 11, port 13. So identifying the service, whether we are using a TCP or UDP. Similar way, we have a UDP also, we have a same thing. We have to that well-known ports used in TCP as well as UDP. So that identifying the service is very, very important in TCP as well as UDP. Okay. The next one, I told you segmentation. Okay, what is segmentation? My higher unit will be, because my packet size will be very high. For example, I'm taking the message, hello, how are you? This is my data I'm going to send. Okay. Okay. It seems to think that this is a longer message. Okay, so what it will do, it will split into segments. First segment, second segment, third segment, fourth segment. So 1 by 4. 4 is the total segments. 2 by 4, 3 by 4, 4 by 4. This is segmentation. I am dividing my entire message into small parts. Okay. And once I am receiving, I have to get it in a proper way. For example, R is first, R, how, hello. That means my segments are not in rearranged. It's not correctly rearranged. So it's a wrong way. So I have to reassemble. So definitely 1 by 4 has to reach first, then 2 by 4 and 3 by 4. and 4 by 4. Yes, this is my segmentation concept. Have you understand? So I am sending my packet. It is a very large unit now. It will be splitted by a unique number. Okay. Once there will be a segmentation is there, once it is transmitted, it will be rearranged in a order. Then only we will receive the correct message. So the segmentation is also one of the most important work of how we are saying identifying a service. The second important work of the transport layer is segmentation. Yes, have you understand? Have you understand, ma? Students, kindly acknowledge me. Students, kindly acknowledge me. Have you understand the segmentation? Students, are you listening? Kindly acknowledge me.
Yes, ma'am.
So, segmentation, my message will be segmented and numbered and sent and then reassembled. That is segmentation. The next one is multiplexing and demultiplexing. You listen. Multiplexing and demultiplexing. Multiplexing, you all know the network devices will be here. Okay, and whether I can receive it through the telephonic or system or maybe a server, the data will be here. It will be a voice call and here it will be a message, whatever may be. But as a network device, it doesn't understand that it will be multiplexed. Okay, multiple input into single output. That is multiplexing. So multiple input I will get it, one through telephonic network, one through the wireless LAN, and one through the server and all, whatever may be my network devices. We all know all the network devices, they were saying that hub, repeaters, bridges, routers, whatever may be, that it is multiplexed. Okay. Once it is multiplexed, how I can differentiate the data which is sent through the telephonic network, which is sent through the computer and while sent through the receiver. Now, each and every packet, have you seen that? My packets have been in a different color, yellow, green and brown color. So how it is differentiating now, not by the color. In multiplexing, how I will identify now using two important principles: TDM, time division multiplexing, and FDM, frequency division multiplexing. These two are the most responsible to split that, and one finally reach into the network device. Demultiplexing, how my multiplexing working here, automatically my demultiplexing will be works, and this demultiplexing will split the content and it will finally reach the destination. So once you understand, we are doing the serial communication, whatever may be the network and whatever may be the packet where it is, everything it is multiplexed, but multiplexing the frequency range. That's why while we are learning the Bluetooth and all, also we told you, this is the particular range of frequency only my Bluetooth protocol is working. The similar way, while sending the packet, it will be identified with the frequency domain and time domain. Then it will be converged into a single line and all the data will be passed. And in the other side of the network device, everything will be splitted according to the frequency division or time division concept, and then it will reach the final destination. So how I told you the transport layer doing the responsibility of identifying the service, segmentation and multiplexing and demultiplexing. These are the things. Then we will see the next important work of transport layer. Okay. Flow control. We all told you flow control, error control, congestion control. Actually, we will study in detail about all this control. This is the introduction part only. So you understand that first you look up on this figure. So I'm getting 3 data from my sender. Okay. Why? Because now my window size is 3. Then obviously I will send my acknowledgement. Even if I am sending 5 here, send 1, send 4 and send 5. My receiver won't acknowledge because my window size is 3 now. Automatically, accordingly only, it will get that. Okay, and one more thing, this is explained with the window size, and this is also explained with the sequence number. I told you in the segmentation how I am splitting my data into segments and how it is rearranged in the sequence. The same way, the sequence number is that. So once you see to that, I'm receiving all my segments in a sequentially, and I will acknowledge that I have, because we were looking only TCP. TCP means it's a connection oriented protocol. Okay, so after receiving, I have to acknowledge it. But once you understand that, I am lost some of my segments in that due to some congestion, due to some network traffic flooding, all these techniques, any of the packet is got congested. Automatically, what happened now? I can understand that my packet is not received. My windowing size is that. Definitely, I have missed some of my data. So to that, there is a congestion. So the sender has to resend, then only I can able to reply. So all this will be doing the flow control, error control. Error control, we all know that counting the headsum control were there, and conjunction control is also there. So any of my sequence should not be missed. It should be equal to the window size. If the flow control I have received from my sender side, I have to acknowledge it. That is very, very important. Yes. You understand this, Ma? Yeah. So this is my important work of transport layer. We have seen that identifying service. That means whether it is a TCP based service or UDP based service. Multiplexing and deep multiplexing. Whether I can send it through any of my communication, but anyway, once it is multiplexed, definitely it is demultiplexed. Segmentation. The packet is larger unit. It has to be segmented. While it is segmented, it has to be in an order sequence. While it is sequenced, it has to be reassembled in the destination side. Okay, error correction and flow control. So these are the major functions of my transport layer, which is responsible for all these functions. Have you understand the introduction part of the transport layer? What are the major functions? Have you understand? Have you understand, Ma?
Yes,
any of yeah, Alina. Okay, thank you, Ma. I think Alina, I don't know the gender I'm saying. Okay. Yeah, this is the final figure out for the transport layer. Whatever I told you now, all this, whether it is maybe a IP telephony service or multiple web pages, transport layer services, instant messages, videoing, everything, whatever may be, the transport layer will take the responsibility of multiplexing, error checking, data segmentation, all this work. All this will be taken care by this transport layer. Okay. So you see to that in a different color, they have mentioned to that multiple applications are that, but it's not depends on color. It depends on a frequency as well as the time division concept. And you all know that I am not sending in a single segment. I'm just splitting my data into several segments. And while reaching, I have a responsibility of error checking whether I have received my data correctly or not. Okay. Now we will go into the segment. Okay. A packet in a TCP is called a segment. That is, segment is not a new terminology. We will use to say in other terminology, packets and all we used to mention. But The packet in a TCP is called as a segment. Okay, now I told you how that is streaming delivery. I think it's the same thing only, how my sending process as well as receiving process. My stream of bytes will be sent from my sending side and the same stream of bytes will be received, but they have given in a steps. This is one step. The next step in detail. Okay, just streaming, sending means it's not a thing. How, because multiple data we will receive. So how it will be sent now? It is like a buffer like system. Okay, every time I'm receiving my data, this buffer system will rotate to write every byte at a time, and then I'm sending the next byte to send. Similarly, in the receiving also, I will receive the byte, and some of the byte I won't say not sent, and some of the byte which is not be in a read mode. And finally, once I receive the byte, and then I have to give for next byte to read. So there will be a buffering element to get the data as well as to send the data as well as to read the data. All this will be inside that TCP element. Okay, these are the streaming delivery procedure. Okay, okay. Once I'm sending, just I'm sending the streaming of bytes. You just see it's a segment. So segment, you all know that there will be a segment numbers will be there, and according to all the segment numbers only, it will be reassembled and it will be sent to the receiving side. Okay, so I think you understand. This is the streaming delivery of TCP, how my bytes is sent, and how the buffer will take the responsibility to read it, and how it will be sending in a segments. Okay, I think while I'm saying that, the number which is generated by the segments and the sequence, it's arbitrarily generated, and you all know for that we won't keep any segments or sequence number and all. Why? Because now for all our data has to be protected, so the bytes of data be transmitted in each connections are numbered by the TCP protocol only. So the numbering system, it will generate arbitrarily, it will generate the number for that. Okay, now I will tell you one small example for that. You kindly listen. Just assume I'm going to send some 5,000 bytes of data. Okay, and you all know the 5,000 bytes of data, I can carry only 1,000 bytes of data at a time. Okay, and you all know my sequence number, my sequence number is 10,001. You just see I'm having 5 segments. Why? Because now totally I'm going to have a 5,000 bytes. In 5,000 bytes, each segment have a capacity to send 1,000 bytes at a time. I can capable to send only 1,000 bytes at a time. So when you see my sequence number, how it is sending the sequence number now, I told you the best example. Hello, how are you? Okay, you see, hello, how are you? This is my message. Okay, in that message, assume this is a 1,000 bytes message. Okay, assume this is a 1,000 bytes message. So this is my single byte. Sorry, this is my single segment. Here it will give the number now. This is 10,001. Are you clear? And this is 10,002. And this is 10,003. And this is 10,004. Are you clear? So this is the way the TCP will give the segments, and first it will decides the segment capacity. According to the segment capacity, it will assume the sequence number, and the sequence number will be starting from 10,001 to 11,000. So obviously the segment capacity is 1,000 bytes. And similarly, the next segment 11,001 to 12,000, 12,001 to 13,000, 13,001 to 14,000, 14,001 to 15,000. So I am sending each segment with the capacity of 1,000 bytes. I'm totally sending 5,000 bytes, and my sequence number, which is started from 1,000 bytes now, it is starting from 10,001 to 11,000. Is clear how it is dividing the segments? Okay, that I told you that the value in the sequence number field of segment defines the number of assigned to the first data byte contained in that segment. So in the segment 1, I'm saying 1000 bytes now. So my sequence number is also will be in that ranges. Okay, that is only the meaning of this. Okay. So now we will see to that TCP segment format. You all know each and every explaining any of your protocol, writing so many stories won't help you. Definitely you have to draw this header. Header is one of the very important of any of the protocol. So finally you are supposed to write all the protocol header, then only it will helpful for you to write the exams. So now you see this is my TCP segment and this is my TCP header. You all know the packet in a TCP is called as a segment. Okay, so you see this is my header. My header consisting of 20 to 60 bytes and this is my data. Okay, while I'm coming to my header. Okay, so here I told you how network layer is speaking about IP address and data link about the MAC address and all. Now, while coming into the TCP, we used to say port address. That is one other thing. And while we are seeing the first point of transport layer, we have seen that it is most responsible to take the service and port number. So that port address is very, very important in the TCP. So this is my source port address and this is my destination port address. Are you clear? Source port address and the destination port address, sequence number. You all see it is a 32-bit sequence number. Okay, so sequence number according to my segments, my TCP will itself give the number of bytes, it will give the sequence number. Acknowledge number, we all know that TCP is working on the acknowledgement because it's a connection oriented. Whenever I am receiving any data, if I am sending as well as I am receiving, and that I have acknowledgement. So without acknowledgement, the TCP protocol won't establish any connection. That's very, very important. The header length, we all know that header length is similar to that where we learn in other sites like Ethernet or wireless LAN, or that will be mentioned in the HELN, that is header length. You all know this is a reserved bit. It is not used for this. This 6 field I will explain you in the next slide. Okay, and this is the window size. While we are discussing about the window size, I told you my window size is 3. That means I can be able to receive only 3 files from the sender side. Okay, so not 3 files, 3 packets or 3 segments from the sender side. That is my window size. And you all know this is not checksum. This is for error correction. Okay, and this is for flow control. All this will be checksum will be responsible for the checking there. Then urgent pointer. Okay, once you know that when this urgent pointer will be activated now, the 6 field we are having now. Once this urgent field have been high, automatically my urgent pointer will be there. This is for options. Okay, so while I'm explaining the TCP header, how we have a IPv4, IPv6 header now, but it is a very simple way, not a complicated way. I have a source port address, destination port address, sequence numbers, acknowledgement numbers, header length should be exist, window size for that definitely should be there, checksum, and then we will see to that what will be in the what will be our goal. From that you can understand what is the purpose of this. Okay, now you just see these are my control fields. Okay, URG. I told you that the 6th field I have given you a urgent pointer. Okay, urgent if anything is there. Okay, ACK, acknowledgement is valid acknowledgement or not. So that header, PSK, request for push this data, push, okay, reset the connection. Synchronize the sequence number. That's very, very important. Okay, because why I'm saying synchronize now, sender won't send the data first. First, the connection establishment is very, very important. So first it will send the synchronized bit. Once the synchronized bit is received from the receiver side, receiver will send the acknowledgement. Once it sends the acknowledgement only, if these two are get matched, then only it will send the data. So I think the synchronization field and the acknowledgement field are very important field while I'm sending as well as receiving the data. That's why they have mentioned in that. Fin is for terminate the connection. Okay, that is for that. This is and urgent pointer is valid. acknowledgement is valid and reset the connection. For this yellow color will have been representing. Okay. You all know these are the well-known ports used by the TCP, and these are the port numbers. Okay, you all seen that. I think it's not necessary to remember all this port, but you have to understand that while come to the TCP, the port number is very, very important. So these are the port numbers, and these are the protocols, and these are the descriptions for that. Okay, I told you in that TCP header, we have checked with the port number, we checked with the sequence number, we checked with the acknowledgement bit, and we have checked with the window size. And one more thing is checksum. That is also very, very important in the TCP. So TCP is, I think, this is the doubt which is asked by the Nitesh. How come, ma'am, this will responsible? Everything one will be, that will be like a padding, it will be added, and the entire frame will be set. So application layer, okay, while you see this, my application layer data. So my TCP header, what the TCP header will add? It will add the port number. Okay, then it will add the segments. Then it will add the sequence number. All this will be the TCP header. You all know this is the TCP header we have studied now. Previously, we have seen that TCP header, source port. All this information will be in the TCP header. This is application layer data. Okay, we will receive the data from the application layer to TCP. So they are explaining in the application layer, all the application layer, session layer, and presentation layer will be in the same thing. So that we will receiving from the application layer, and my TCP header will be added. That's why we have learned the TCP header. And you see to that, once it comes to the network layer, definitely IP header, IPv4 header, IPv6 header, and all we learn. That's why I told you all the headers are very, very important. So that will be further added with the TCP header. And finally, frame header will be there. Then it will be added. Now it will be sent through via the physical layer. Okay. You all understand this is TCP payload, this is IP payload, and this is a data link payload. That's why we have seen this is our second unit, and this is our third unit, and this is our fourth unit. Okay, and you all know pseudo header added to the TCP segment. Okay. So pseudo header, we all know that this is the TCP header. We all know that. While comes to the internet protocol, definitely 32-bit source IP address. We all know that it is a IP address of the IP header file will be around 32-bit. 32-bit source IP address, 32-bit destination IP address, and 8-bit protocols will be there, and 16-bit TCP total length will be there. This is my pseudo header, and this is my, you all know, this is my IPv4 header, or internet protocol header, and this is my TCP header. So that's why, and along with that, my data will be sent with the application layer data. Along with all this will be sent with the application layer data. Okay. So this is the layer overview. While I'm telling about how my data for your purpose, they have explained only with this TCP IP model, application layer, and the down layer is network layer. So the application layer, a transport entity, transport addresses will be there. And then while comes to the network layer, the network address is there. Transport address is nothing but my port address they are saying. Network addresses means they are relating the IP address. Okay, now this is our very important point of TCP, how the connection is established, how the data is transmitted, how it is terminated, how it is reset. We all know that the connection establishment, data transfer, connection termination, connection reset, we have all the 6 ACK, URG, ESC, SYN, synchronization bit, all this are responsible for the TCP. Okay, now please students understand this, why very, very important in TCP layer, why this connection are very, very important on Allah. Just listen, this is my connection request. Okay, you assume this is my A is my sender and B is my receiver. Okay, so connection request I am giving. Okay, once a connection request I have received from A, I am giving connection granted. Okay, so connection granted means automatically my data will be there. Okay, in the data I am transferring some 20 lakh to one of the account. Okay. Now what happened in this connection request, we all know that it have a multiple segments, multiple sequence and all. We seems to that if some of the segments are missed, so what happened, the A sender A, once again it is resending the connection. It is resending the connection. So duplicate, same connection is requested once more. But the B cannot understand. Okay, the same connection is I have received. So it is giving the granting. Then what is happening now? Once it is granted now, then automatically the data, what the A will do now, it will send again 20 lakhs to the same account number. So what is the problem now? We cannot able to go with this request grant data. Always I have to match that number. So the numbering is very, very, very important. So once the connection is request is there, connection grant is there, my data have been processed now, there is a problem if my connection request is got duplicated due to any of the reasons, whether it have been mismatched or the bandwidth is high or the network terminated, whatever may be the reason. Once again, my connection is requested again. If I am sending again the same data, even it is a most important thing, not a data rather than the money, my connection will lost. So sorry, my data, my money will be lost. So with that, the sequence number, synchronous number, all the data are very, very important while I am establishing the connection between A and B. Are you clear? Are you clear, ma? Okay. Now you all understand. TCP always follows three-way handshake signal. Kindly take down the figure for this, because this is one of the important figure where your entire flow control, conjunction control, all will be following this methodology. So this is the order idea from Tomlinson, how the three-way hand signal is identifying. This is the request. For this request signal, this is my grant signal. Then only I have to transmit my data. So that we have a three-way hand signal is there. Yes, kindly draw this diagram. This is one of the important diagram in the TCP connection management. Okay, so you just see SYN, synchronization bit. Okay, we all know that my A is sending synchronization bit, and you all know that it is sending with the sequence number X. X is my sequence number. Okay, now B is my receiver. It's saying that, yeah, I received your synchronization bit and I am sending acknowledgement. Okay, but it is not an acknowledgement. Simply it won't send the acknowledgement. What is my sequence number? X. What is my sequence number, ma? X. Okay, my sequence number is X. Now I am sending the acknowledge number with X plus 1. X plus 1. And you all know that my B also send the sequence number with Y. Okay, you understand this? This is sending by A. My A is sending this, and this is again my B is sending. Okay. Now what the A will do now? What is the acknowledge number of B? X plus 1. Now it will be the sequence number X plus 1. And now this sequence number is Y. We all know that that will become an acknowledge number here, Y plus 1. So it always match this acknowledge number with this sequence number. If both are matched only, it will send the data, or else it won't send the data. Are you clear? I'm sending my address with 1000. Okay. And we all know it's not an address, it's a sequence number. So my acknowledgement number will be what? 1001. Okay, and again it is generating 2000 with another sequence number. Once again, the same A is sending 1001. So what it is checking for that now, this sequence number and this acknowledging number should be same. We all know this sequence number and acknowledging number, it's arbitrarily generated numbers. Okay, so to that, my connection will be a trust oriented. I may do that bank transfer because I have a three-way handshake business. Connection establishment, synchronization bit is there, acknowledgement is there, data is there. When the data will transmit it now, my sequence number is matched with acknowledgement number only. It will establish the connection and it will transfer the data from A to B, and then automatically it will be established the connection. So that is why it's a three-way handshake, and this is the idea from Thomilson. It's a famous three-way handshaking model. Yes, have you all any doubt on this? Have you any doubt on this particular one, Mark? Have you any doubt? Students? You have seen what is the case if it is duplicated. Okay, my sequence number is X. Okay, my acknowledging number is X plus 1. Again, I'm sending sequence number is Z now. My acknowledging number will become Z plus 1. So it can understand that my acknowledgement number is not matched with this sequence number. So automatically the connection will be abort. Okay, it won't transmit. Even the duplicate data is sent automatically. I can understand that in this case, my sender acknowledgement number and that is my acknowledging number is not matched with the sequence number. In the three-way signal, automatically it will abort the signal. And some more cases also there. So this is about the TCP and all. Okay, I think this is on one of the best way they have explained with the numbering. Not I'm telling X, Y and all now. 9001. Okay, so what it will do? It will take the 9002. Synchronization is 1. And again sequence number is 5001. While it is receiving, again it will send 9002, 5020. Now when you go with that number, this acknowledgement number, the sequence number, this sequence number and this acknowledge number is matched, automatically there will be a client and server will be accordingly, and the connection will be established and it will send.